Okay, everyone, welcome back. This is the Amateur Radio General Class, session number 22. And we will go straight into the theory for today's session. Okay, so we are still under the electrical and RF safety section of the course. So we go straight into a standard that is utilized for establishing proper safety procedures and settings and parameters when we work with electrical equipment. So one publication by the NFPA is called the NEC, or the National Electrical Code. The latest edition is the 2020 version. And up on your screen is an example of what the cover of that text or that book looks like. Very useful document if you can get your hand on either the actual code itself or its interpretations. But we need to know for the exam that the NEC, or the National Electrical Code, covers electrical safety for us as amateur radio operators. It's a very useful document for us to refer to when it comes to safety in our amateur radio shack, as we would call it. So we need to learn also for the exam that we were talking about things like current carrying capacity of conductors. We need to make sure that those conductors that carry current for us when we use to power our equipment, that the conductor is of the correct size. We don't want to cause a fire, for instance. So we need to make sure that the conductor also matches the fuses or the circuit breakers that we put to protect those circuits or those systems as well. And we need to learn for the exam a couple of the sizes of the conductor and its matching fuse or breaker sizes. And we have them circled here on the screen. But just for your information, there are a couple different sizes of wire that we can use. And we also need to learn a little bit about the AWG, or the American Wire Gauge System. And one thing we should point out is that the wire is given by a number. So for example, this wire here, fairly thin wire, is called 18 gauge or number 18 wire. Then there's another size here, number 16 or 16 gauge wire, or 16 AWG. There's also AWG number 14. And notice the wire gets progressively thicker, or the diameter gets larger. We are up to AWG number 12. And notice AWG number 10. Number 8, number 6, number 4, number 2. So by now, you should get the idea that the smaller the number, the larger the diameter of the cable, or the thickness of that wire in the conductor. So the opposite is true. The larger the number gets, the smaller the wire gets. So that's just for your information. But there are two sizes that we need to learn and know about for the exam, and that is 14 gauge wire and 12 gauge wire. And we also need to know that the current capacity, or the current carrying capacity, in relation to the breaker or the fuse that we may put on a line. Let's say we are supplying radio equipment using these wires, these types of wires. For powering the equipment, we need to know what size breaker or what size fuse that we can put or should put on this particular size cable. So we may remember from our last sessions in the technician class that, of course, the size of the wire, when we think of it, is what will determine the current carrying capacity, also less resistance. And then we also used the water circuit as our analogy when we were talking about current flowing in a conductor. So therefore, the thicker the wire or the bigger the pipe, the more current can be carried. And that is what we are talking about here. So this smaller size wire, number 14 gauge, we will put either a fuse or a breaker that's 15 amp in value. And if we use a 12 gauge wire, number 12, smaller in number, but notice it's a thicker wire, we use a 20 amp breaker. So that is what we need to know for exam for the number 12 gauge wire, or what we say AWG number 12. It's a 20 amp breaker, and for an AWG wire number 14, it's a 15 amp breaker. If you want to learn one way to remember it, for the 14 gauge, it's a 15 amp, so it's 1415. And therefore, number 12 will be the other number, which will be 20. So think of 1415 if there's a way you need to remember it. 14 gauge, 15 amps. And then 12 gauge, 20 amps. However, it's just these two that you need to learn for the exam, so commit it to memory. And these are the bullet points that we have here. And we said that it's for safe use, you should not exceed the current. In other words, if you're using 14 gauge wire, you should not try to exceed 15 amps going through that. If you need to go to 20 amps current, you need to go to the thicker wire. Just like if you have 1/2 inch PVC carrying your water versus probably a 3/4 inch PVC. You need to carry more water. You need to go with the larger size diameter pipe. Same thing with the current rating as well. So need to learn this for the exam, what the NEC is, as well as what breaker size or fuse that you use when you're using number 14 gauge wire and number 12 gauge wire. And sticking to the concept of fuses and circuit breakers. So remember, a fuse or a circuit breaker is to protect the circuit, right? The fuse will either, as we say, blow, or the breaker will trip. But we need to learn for the exam and the general class that if you have a 4-wire conductor, so you have ground, neutral, and line 1 and line 2, or live 1 and live 2. For a 240 volt supply. So that's what we're showing here. This is inside of your breaker panel, and this is the back of your outlet, electrical outlet. So you notice you have 4 wires. You have the ground, you have the neutral, and then you have the 2 line wires. Okay, so therefore that's 4 wires. And we need to learn that these 4 wires, the ground, the neutral, and the 2 lines, the only lines that we need to put or should put a breaker or fuse is on the lines that carry the voltage. We should not put a breaker or fuse on the neutral line or the ground. We do not put fuses there. It's only on the lines that carry the voltage. So in the case of a 240 volt, where you have actually 2 lines carrying that voltage, that's where you will put your breaker or your fuse, and we need to learn that for the exam. As we say, only the 2 wires carrying voltage in a 4-conductor connection should be attached to fuses or circuit breakers in a device operated from a 240 volt AC single phase source. So we need to learn that. We do not put fuses or breakers on the other conductors, meaning the neutral or the ground. It's the voltage wires or the line wires that we will have those breakers or fuses connected to. And this is why we have this trusty diagram here that will hopefully illustrate that. You have the supply coming in here, and notice that's where you have the breaker, or if it was a fuse, that's where you will have it. And we do not fuse the ground, and we do not fuse the neutral connector. That would be a mistake if we were to do that. And it could also be a very costly or dangerous mistake. Okay, so we dealt with GFCIs before in the technician class. So on the right-hand side here is an example of what a GFCI outlet looks like. So you may have this in your kitchen or your bathroom or any area that may be close to water. You'll find this sort of receptacle outlet. And it's for safety purposes. But we need to know how the GFCI works. And below the GFCI, we have a little circuit diagram that shows how it actually operates. So you have the supply coming into the GFCI. So you have the line, and you have the return or the neutral, and then you have the ground. So what happens inside of the GFCI? The GFCI looks at the line current that's flowing through, and then it looks at the current that is returning via the neutral back to source. And if it detects that there's a difference between the two, it must mean that some of that current is going to ground, and therefore it detects a ground fault and it will trip or it will open the circuit. So that's how a GFCI works. It actually monitors, using some circuitry, the current flowing through the line and returning via the neutral. Because whatever goes in is supposed to come back out. That's how the circuit works. But if some goes in and less come out, in other words, all doesn't come back out, that means some of it is going to ground. And therefore it could be that it's a person that is being electrocuted. So it will quickly trip that. And that's why a GFCI is for safety purposes. And we say that current flowing from one or more voltage carrying wires directly to ground will cause a GFCI to disconnect the 120 or 240 volt AC power line to a device. And this is a diagram internally how it works, but this is what it looks like externally. And we need to know the functionality of the GFCI, or ground fault circuit interrupter. That's what GFCI means. And this is the point here that you'll get on your exam. Okay, so we now come to talk a bit about some other safety apparatus or safety considerations. So first of all, we talked about power supplies in our amateur radio configuration. We need to supply our transceiver or radio. We need to power our equipment, and therefore we may have a power supply that's powering our transceiver. Now, if we were to open our power supply, now sometimes there are very dangerous voltages inside of our power supplies. We may have a AC line voltage of 120 volts AC. If we were to open that power supply and it's plugged in and we touch that supply inside of the power supply, we may be in for a pretty nasty shock. So some power supplies have a feature that is called an interlock switch. So if we were to look on the right hand side, bottom right hand side here, this is an interlock switch. Part of it goes on the chassis and the other part may go on the cover. So if I were to unscrew the screws that's holding down the cover and I remove the cover, this piece is removed with the cover, and therefore it detects that, and therefore it will probably open the circuit. So therefore no live power will be existing inside, and that is considered an interlock switch, and that is a safety component inside of some power supply. So for the exam, you need to know that a power supply can have that interlock switch to ensure that dangerous voltages are removed if the cabinet is open. Concept of an interlock. Okay, also we need to discuss using a generator as hams, as amateur radio operators. We may have different alternative power supplies. For example, in a disaster situation, or when we have bad weather, like what's happening in Trinidad and Tobago these couple of days, not only Trinidad and Tobago, the Caribbean, as well as the US and so many other parts of the world, we may be without power and we may want to use a generator. That's actually pretty standard practice for emergency communications as amateur radio operators. But we also need to be safe. We need to connect it safe. We need to use it safely. So we need to be aware that if we're using a generator to power, let's say, our amateur radio equipment or equipment inside of our home, we need to make sure that we have disconnected the supply coming from the utility. We cannot have our generator somehow plugged in at the same time to equipment that is somehow simultaneously plugged into the utility supply. That is a definite no at all. So we have to make sure that before we plug our equipment in, we disconnect the incoming utility power feed. And that's a question in the exam. Some would say that's obvious. Well, you know what? It might be, but it has happened, and it caused, you can cause a major damage. You can have a house fire. You can do quite a lot of damage. You can be electrocuted. So many things can happen if that were to occur. So just make sure you disconnect before using your generator. Also, we need to be aware that generators, a lot of them will be powered maybe via gasoline or diesel. And therefore, we need to locate those generators not inside of the house. You would not want to put a generator inside of your home. You would want to have it outside in a well-ventilated area so that the exhaust fumes, those exhaust gases do not come inside of your house. And that could be very dangerous. So we say that any emergency generator installation should be located in a well-ventilated area. Don't put it inside of your house. Also, we say a primary reason for not putting especially a gasoline fuel generator inside an area that's occupied by humans or any other living being is the danger of carbon monoxide poisoning. And that can kill people. You may not even know it. Carbon monoxide is in the house and the person may just fall asleep and die due to carbon monoxide poisoning. So bear that in mind if you have a generator or have any intentions of getting a generator. Safety first. All right, so another danger as harms we may encounter is that of lead poisoning possibility. Why or how come, why are we concerned about lead poisoning? Well, as harms, we are doing electronics. We may have to repair our transceiver, we may have to repair our power supply or some piece of electronic. And on the diagram here, we have a spool or roll of solder. This is what we can use to repair circuit boards after we replace a component, and then we have to use a soldering iron and solder to put the component back. But this solder that we will use contains two components. One is lead and the other one is tin, and it also can have a core of flux inside of there. But because it has lead and tin, lead is one of those substances that can be very dangerous because you can have lead poisoning. And if we were to look at our spool here, we will see that has that, you see the SN, which is means tin, that's the symbol for tin, and PB is it means lead. And you might be wondering, well, how come SN is tin and PB is lead? Well, SN I think is the Latin word for stannum, and that's why SN is tin, and PB used to be plumbum, and that was the Latin word for lead back then. So PB is the symbol for lead, and once you see that, that means you have to handle this substance very carefully, because one of the dangers that you have from soda that contains lead and tin is that the lead can contaminate food if you do not wash your hands carefully after handling the solder. So as an amateur radio operator, you need to be aware of that. Don't go and solder something and then just go and touch food and eat it or give it to other people. You have to make sure that you carefully wash your hands off. So all of these things are under safety as an amateur radio operator. All right, so we have basically just finished the safety section, and we are going on to the last topic in our course, which is commission's rules. So we have just a few slides to go, and we will be running, let's say maybe a 15 minutes or more beyond our normal time, just to make sure that we progress. So let's go. So we are doing the general class level in the amateur radio course. We would have dealt with the technician class before, but we are now doing general. And we need to be aware of some of the privileges that you will have when you become a general class amateur radio operator. So each of the various classes as an amateur radio licensee will contain different frequency privileges, meaning that when you're a technician class, you have permission to transmit on certain parts of the bands and spectrum, but you do not have permission in other parts of the band. And sometimes you don't have any permission on certain bands at all. And when you upgrade to general class, you may find that you're getting additional privileges, additional spectrum, either within the same band, you can use more frequencies within that same band, or bands as a technician you didn't have, you now have as a general class. But also bear in mind that after general class, there's the extra class. An extra class has some additional privileges that you as a general class wouldn't have, and also as a technician class you wouldn't have. So the various classes of licenses come with different privileges as far as the frequency range that you could transmit on legally are concerned. So we need to learn for the exam that as a general class license holder on the HF and MF bands, you have frequency privileges on these frequencies. You have 160 meters, 60 meters, 30 meters, 17 meters, 12 meters, and 10 meters. So you just simply need to learn this for the exam, that as a general class, you have privileges on these frequencies. So on the top right here, we have the frequency chart, the band plan in a chart form. We have another slide with it blown up, of course, to see. But we have excerpted the various bands as they have indicated to us here. So let's dissect these diagrams so that we can understand what these diagrams are saying. And once you learn how to read this, it actually becomes a lot easier. It could be a little cryptic the first time you look at it. It's like, what is all of that? So let's just go through how do we read this chart, simple way. So we did say that as a general class, you have 160 meters, 60 meters, and so on. And if you could have seen this diagram here, you will see 160 meters, 60 meters, 30 meters, and so on. So we have just exploded that out a bit. So 160 meters, when we look at it, we'll say 160 meters is between 1.8 and 2.0 megahertz. And we have a chart later on that, brings that out a little in terms of comparing and contrasting. However, for 160 meters, that band is between these two frequencies here. And notice that the general class, you have privilege across that spectrum here. And you might be saying, well, how do I know the general class has that? So this letter G that is next to the band, you see E, A, and G. Here's the key. E is amateur extra, A is advanced, and G is general. Of course, T is technician and N is novice. So G is general. So once we see that G here, that means you have this privilege here. Whatever that row is, you have that privilege. So then you'll see colors as well. You may say, well, wait a minute, why do I have colors as well? But those are the different types of modes, and we'll come to that in a little bit as well. Also, if we were to look at the 60-meter band, when we look at the 60-meter band, you see E, A, and G again. There's that G, so general class. That means you have those privileges as well. So you have privilege on 60 meters. 30 meters, if you look at 30 meters, again, you see E, A, and G. And guess what? That means you, as a general class licensed operator, will have privileges on 30 meters. And so on, and so on. But let's go to the 80 meters here, right? Notice it's a bit different. We'll come to that in a bit. Notice the general class does not have the full part of the spectrum. The extra class, which is the E, has everything. Notice the advanced class, which is no longer, you cannot become a newly licensed advanced class. But persons who are grandfathered and have advanced class licenses, this is where they can operate. They still have a little gap in the spectrum. Notice the lower part of the phone band here. They can't transmit there. So the class that has access to everything will be the extra class. But as a general class, notice under 80 meters here, you have this part of the spectrum and not the entire thing. So this first bullet here simply points out that a general class, you have privilege on 160, 60, 30, 17, 12, and 10. You have privileges across there. It's very, very much equivalent to the advanced and the extra class. So you need to know for your class what privileges you have. And this band chart here is what will give you that information. So the next point that we make here is that on the 80 meter band, which is this one that we're looking at here, the general class portion of the band includes 3523 to 3600. So we just need to, that should be 3525 to 3600. So we just need to know that that is the part of the spectrum that you have. And the question that they will ask you in the question pool is what frequency is within the general class portion of the 80 meter band? And the answer will be 3560, because 3560 is between 3525 and 3600. So if you look at it here on the screen, this is where a general class has access to inside of there. And also the extra has it, the advanced has it, and even the technician and novice has it. But what they can do is what counts. They don't have phone privileges here as a technician or a novice. But you as the general class, you have that privilege inside of there. And the frequency range is 3525 to 3600. There's a little typo here, so this should be 3525. But you don't need to learn that part for the exam per se. You just need to know that the exam question will ask you for the general class portion of the band on 80 meters, what frequency does the general class operator have? And you need to learn 3560. But this is just showing that 3560 is between 3525 and 3600. That frequency range there that you have as a general class that you are permitted to, they will be asking you for a frequency inside of the range that you are permitted, and that's the answer here, 3560. Okay, continuing with more general class frequency privileges. So we need to know that as a general class, unfortunately, you do not have access to the entire voice portion of the band, because some of that is reserved for advanced class and extra class licensees. So as a general class, you don't have everything. And you need to know that you will not be able to transmit into those subsegments of the band. Those are reserved for the advanced and extra class operators. And we need to learn that for the exam, the part of the band that as a general class you will have access to will be the upper frequency part of the band. And we'll show you exactly what that is in a moment. So the question will ask you what part of the segment for the voice segment for as a general class you have access to, and the answer is the upper frequency end. So let's define or show or demonstrate what the upper frequency end means. So let us look at the 80 meter band, for example. If you were to look at the spectrum here, the 80 meter band is between 3.5 megahertz to 4.0 megahertz. That's the spectrum. That's the 80 meter band. Now notice the general class, which is G here, does not have access to the entire of the 80 meter band. The extra, which is the E here, has access to the entire part. But the general class can do phone, which is voice, in this part, and can do data and so on in this part. But notice the difference here when you look at the extra and the advanced class. The general class has this upper frequency end, and the advanced has more, but it's also towards the upper end, and the extra actually has all of it. But notice the lower end, the general class does not have any part. All of this is missing from the privileges of the general class. So that's what we mean by the general class has access to the upper frequency end as opposed to the lower frequency. Upper meaning closer to the 4 megahertz, lower would have been closer to the 3.5 megahertz. So that's what they mean by the upper frequency end. And you need to learn that for the exam, that the general class is not permitted to use the entire voice portion. Notice here the extra can use the entire portion. Look at all of this here. The general class could only use this little range. So that's the point here. The general class does not have access to the entire voice portion. But the portion that the general class does have access to is on the upper portion or the upper frequency end. So hopefully that has explained what they mean by the upper frequency end that the general class has access to. A couple other points that we need to simply learn off for the exam. So for the 75, sometimes called the 80 meter band, right? They'll try to tie you up with that. For the general class, for the 75 meter band or the phone band, a frequency inside of there that you have access to is 3900. How do you get that? Well, let's look at it on the diagram here. So the 75 meter band or the 80 meter band as it's called, it goes from 3.5 to 4 megahertz. But we are talking here about the phone band. So this is the phone portion in green, meaning that you can do voice, but a general class can only do voice from this start here, which is 3800 to 400. So they'll have a choice of frequencies, and some of them will be outside of this range. But notice 3900 is the answer because it falls between 3800 and 4.00. So that is how they get that answer. When they ask you the question for a general class, what frequency does that person have for the 75 meter or the 80 meter phone portion of the band. So this is the phone portion in green, and this is the line that shows you here the range that the general class has access to, 3.8 to 4.0, and 3.9 or 3900 falls between the upper and the lower end of that range. Similarly, they will also ask you for the same general class licensee for the 40 meter band, what is a frequency that is valid for a general class operator. Now they add inside of there the ITU region 2, and we'll come to what ITU region 2 is in a little bit. But for now, that's sort of extraneous information for our purpose. We just want to know for the 40 meter band. So if we were to look at the 40 meter band section, now remember all of these blocks came from this band frequency chart here. So we've just exploded them a bit so you can read it a little more clearly. So this is the 40 meter band. And we notice that the band for the general class here, it starts at 7175 and it goes to 7300. So notice that the frequency 7.250 falls inside of there. So that is in fact a frequency that the general class can use or can transmit on. Also, they will ask us a question about the 20 meter band, again for the general class operator. And they'll tell us about the phone portion of the band, and they'll ask us what frequency. So if we were to look at the 20 meter band here, notice the 20 meter band is from 14.000 megahertz to 14.350 megahertz. That's the range of the 20 meter band. Those are the frequencies that occupy the 20 meter band or comprise the 20 meter amateur radio band. And the phone portion of the band, notice, is from here, 14.225 to 14.350. Why? Because G is for general class and green is phone. This is the range of frequencies that a general class can speak on or can use the phone mode on 20 meters, 14.225 to 14.350. And notice that the frequency of 14.305 is in fact inside of here or in this range. So that is why this will be a correct answer. Any other answer will be outside of that range and will be incorrect. So that's how they get that answer. So you need to study this and get comfortable with where things are. Last point, and we come to the 15 meter band now. And if we were to look on the right hand side here, we see the 15 meter band. The frequency range is from 21 megahertz to 21.450 megahertz. That's quite a big or wide range of frequencies here for the 15 meter band. But notice the general class only has access from 21.275 to 21.450. And therefore, the answer that they have here is 21300, which is inside of this section between 21.275 and 21.450. So again, they will try to tie you up sometimes using megahertz and sometimes using kilohertz. You know that to go from kilohertz to megahertz, you just divide by 1,000. So 21300 kilohertz is 21.300 megahertz. So don't let the change of units from megahertz to kilohertz be, tripping you up at all. Right, so you need to study this slide some, learn the bands, frequency ranges, but these are the things you need to learn for the exam. But it's important that you understand how this is the correct answer, or why this is the correct answer, how they get this as a correct answer to the question when they ask you for the particular class of licensee, the meter band, the phone segment, what frequency is permissible. It's this chart, this frequency chart that is used to make that determination, and this comes from the regulations for amateur radio operators. I have a little diagram on the left here that shows a map, which is more exploded in another slide coming up shortly, that shows you the ITU region. So this is ITU region 2, this is ITU region 3, and ITU region 1. So we will see that a little more clearly in a slide coming up, but that was the point that they made here about ITU region 2. Okay, so we're continuing on the 10 meter band. A control operator holding a general class license will have the same privileges as the advanced and extra class. So notice we had shown earlier in some of the bands that the extra, the advanced, and the general have different privileges. So like this one, for instance, here in the 80 meter band, the extra has all of this. The advanced have a little less, but the general class has even much less. But for the 10 meter band, notice here we have E, A, G side by side. So that means all three of them, the extra class, the advanced class, and the general, actually has access to all of this, or have the same privileges actually. So they will ask you a question in the question pool, and this will be correct as an answer. So for the 10 meter band, notice the 10 meter band is between 28 megahertz and 29.7 megahertz, a pretty large piece of spectrum as it goes, because some of the HF spectrum is pretty narrow, but this is a pretty large, wide piece of spectrum, almost 2 megahertz wide. And they will ask you about frequencies in the 10 meter band that a general class licensee can use. And all of these are in fact correct. 28.020 is between 2800 and 29700. 28350 is inside of here as well. 28550 is inside of here. So all three of these frequencies are in fact correct for the question that will ask you about the 10 meter band and the general class licensee. And this is how you can confirm that these frequencies can be used by general class licensees. You'll see here the G for general class, and you have all of this that you can use. The novice and the technician, however, is restricted. So a novice class operator and a technician class operator can only use this part of the spectrum and these particular modes. All right. We also need to know for the 10 meter band that that's the only HF band that is available for use in repeaters in the HF part of the spectrum that hams have access to. So you need to learn that, that frequency is actually above 29.5 megahertz. So we just put that into the diagram here. So above 29.5 megahertz on the 10 meter band is where you can have repeaters on the 10 meter band. Also, we need to know that sometimes, hams are using different modes and also different frequency bands and interlinking and bridging them. And sometimes you could have a cross-band repeater, a repeater that is transmitting on one band and receiving on another band. But for the exam, we need to know that if we have a 10 meter repeater, which is on the HF part of the spectrum, you can only transmit a 2 meter signal if the 10 meter operator has at least a general class license. So this is what we need to learn for the exam. And this is an example of repeater operation here. You may recall from the technician class and the extra class what repeater operation is, which is you're going up one frequency and it's retransmitting, and then you're coming back on another frequency and transmitting to the other person. So 2 frequencies in use, usually for repeater operation. And as we have it here, a 10 meter repeater may retransmit the 2 meter signal from a station that has a technician class. So remember, technician class operators can use VHF and above. So that technician class operator is using 2 meters. But the 10 meter repeater could only repeat that on 10 meters if the 10 meter repeater control operator holds at least a general class. If they have a technician class, there's no way they can use 10 meter repeater because they do not have frequency privileges on that part of the band. Notice here that only extra, advanced, and general has access to this part of the band. The technician class does not have any access at all. So that's what this point is here about. That person who's running the 10 meter repeater, that control operator, could retransmit a signal from a 2 meter technician class operator, but the 10 meter control operator must have a general class license, otherwise they cannot do it. Okay, on the 30 meter band, we need to know for the exam that phone operation is prohibited. Now remember, when we talk about phone operation as an amateur, we're talking about voice. So if we were to look at the extract or the excerpt from the band chart, we notice here there is no green, only red. So that is RTTY and data. You cannot do voice, you cannot speak on the 30 meter band. And that's what this point is making here, that on the 30 meter band, phone operation is prohibited. You can only do digital modes or data modes such as RTTY and so on the 30 meter band. You cannot transmit. It's a very narrow piece of spectrum also. That's one of the reasons why. You don't have much spectrum in there, so you cannot speak on that. And also, Similarly, you cannot talk, you cannot send images also on the 30-meter band. So we say on the 30-meter band, image transmission is prohibited. And you need to learn these 2 points for the exam. And just look at this here. You see, if we were to look on the right-hand side here, we have a key to what the different colors mean. Red is data. This green means phone, which is voice, and images, graphics. And you have different colors that mean different things. So notice here, for the 30-meter band, it's only data and RTTY, for instance. Right, so another band on HF, 60-meter, and the other one will be 30-meter band. So we need to discuss these. Again, the 60-meter band is a bit of an oddball type of band, at least in the US anyway. It's channelized operations. So again, we have extracted this piece from the band chart, and we show the 60-meter band has 5 channelized operations. So whether using CW or whether using digital modes or USB, you need to know what those frequencies are. Those frequencies are these 1, 2, 3, 4, 5 frequencies that you can use. So the 60-meter band, we say we don't have VFO. You can't just tune to any frequency that you want. You must use these specified channels or these specified frequencies rather than tuning in between. So that's what this point is saying here. For the 60-meter band, you're restricted to specific channels rather than frequency ranges. So notice the previous ones, we have a full range. Even if it's a narrow range, you have the full range. You could tune anywhere inside of there as long as you don't go above the band edge based on the mode of operation. If you notice that, you have a full range here as well. You could tune anywhere, any frequency. You could go 28.345, 29.525, and so on. Any frequency inside of there. But notice for the 60 meters, we can only use these 1, 2, 3, 4, 5 channels. Again, exam question. Okay, so we also need to be aware of the concept of primary and secondary users when it comes to frequency allocation. So the amateur service will be primary on several bands, but we are also secondary on some bands, such as the 60-meter band and also the 30-meter band. We are secondary. What that means is that we cannot cause harmful interference to others, but we must be able to accept interference from them. So we can use those bands that we are secondary on, but if the primary user comes up, we have to give way. That is what that really means. We cannot claim that we were here first and we can use the frequency. No, if the primary service comes up, we have to either change frequency or stop transmitting entirely. So that's what it means to be secondary on the band. It's kind of like a roadway. You can drive on the roadway. Let's say you are a car, but the roadway is really for trucks as primary. But if there are no trucks on the roadway, you can drive your car on that road. But as long as a truck shows up, you have to either change lanes or you have to come off the road. So it's the same thing with when we are secondary on a band. We don't have that right of way. We have to give way to the primary user. And we say that FCC rules designate the amateur service as secondary on some bands, and we have an example here, 30 and 60 meter, and amateur stations are allowed to use the band only if they do not cause harmful interference to the primary user. So we are not the primary user on those bands, we are secondary users. And what do we do? Well, the appropriate action, if when we are operating, we're having a conversation, we're having a communication, a conversation, a QSO, some sort of communication is taking place on the bands that we are secondary, such as the 30 meter and 60 meter band. And a station in the primary service comes up and starts to interfere with our contact. What we should do is move to a clear frequency or stop transmitting altogether. We should not tell that primary user, hello, you were here first. You cannot do that. That's what it means to be secondary. Okay, we did promise a chart, a larger chart showing the ITU regions. And just by the way, the ITU regions are also the same as the IARU regions, the International Amateur Radio Union regions. So we're in region 2. Most of us in the class here are in region 2. We're either in the Caribbean or in North America. So we are in ITU region 2. But this is where region 1 is, all of this. And then there's region 3. Okay, so we need to be aware that for most of us here, we're in region 2. And for the exam that we're doing, the FCC exam, that these frequency allocations of ITU Region 2 apply to radio amateurs operating in both North and South America. So those regulations pertain to all of us in Region 2. But notice that we may have places that we have jurisdiction on, but it's outside of Region 2. A good example is Guam. Guam is actually not in Region 2, but we have to abide by the region in which those countries are located. Even though you have jurisdiction there, the ITU region is what will take precedence and determine what frequency you can use and so on. So we say that frequency allocations may differ in areas under FCC jurisdiction outside of ITU region 2. Okay. Okay, a couple more slides, folks. Now we are running a little bit on the overtime side. This here is just FYI. We like to compare and contrast. So sometimes people have a little challenge knowing what is the 160 meter band, what is the 20 meter band, and so on. So we have it here showing most of the bands that amateurs have access to. So we show that the 160 meter band is 1.8 to 2.2. We show that the 20 meter band is 14.0 to 14.35. and so on. And we also show which is MF, medium frequency, which is HF, that range of HF, which is VHF, which is UHF. And just for good measure, we show where for SSB you will typically use LSB, lower sideband or upper sideband. So this is just really just a reference chart if you need it so that you could do a little comparison and contrasting. Don't need to learn it off by heart per se, but the better you know this, it will help you in your exam. And it will also help you become a better amateur radio operator. The extent that you have a good command of this information that's on your screen here. Again, this is the band chart, a little bit more blown up so that you could see a little better where we got all of those excerpts from. We plucked these things from off of this chart to show the 40 meter band, the 160 meter band, the 80 meter band, and so on. We just pulled this out, but that's where we got it from. This chart here that summarizes the frequency allocations according to the FCC. Right, so we just have about 2 more slides to complete today's theory. So, of course, as amateur radio operators, we have our radio, our transceiver. It's powered via some supply, and we, of course, have a feed line that goes to an antenna. So this is our shack or house or home or building. And this is a tower or a mast, and we have an antenna on top of it. But we also have limitations as to how high we can place that antenna without some sort of permission or registration. So as a ham, you can put up your station, but you have to be aware that the maximum height between the ground level to the top of the antenna is 200 feet maximum. And you can put that up without having to register with the FAA, that's the Federal Aviation Administration in the US, or the FCC, Federal Communication Commission. You can put up an antenna up to 200 feet maximum without having to register that with the FAA or the FCC. But note, there's a proviso that is providing that you are not near or public airport. All right, so 200 feet is the magic number, maximum height from ground to top of antenna. Okay, so apart from the FCC, some state and local governments may be able to regulate what you can do with antenna structures as well. The thing about it is they can specify other conditions beyond this 200 feet maximum and so on. They may have different regulations that they may wish to impose or restrict your installation as an amateur radio operator. But it must be noted that those restrictions or any regulations or any conditions that they may stipulate must be reasonably, or they must be reasonable, and they must reasonably accommodate amateurs in the process. And whatever regulation that they make in terms of your antenna height and structure, it must be some minimum practical to accommodate a legitimate purpose for the state or for the local authority. In other words, they cannot just have arbitrary reason or some random reason, or as we say in Trinidad and Tobago, by VAPs. It has to be some measurable benefit to the state or local authority for them to restrict you. They can, but they must also try their best to accommodate you as an amateur radio operator. Apart from the fun part of it, remember, amateur radio operators also get involved in emergency communications. So therefore, you do not want to be overly restricted, as it were. So just bear that in mind, that state and local governments are permitted to impose regulations on the amateur radio structures that you may wish to have, under the conditions that the amateur service communications must be reasonably accommodated. And those regulations that they come up with must also constitute a minimum practical to accommodate a legitimate purpose of the state and local authority. So that's how it's written here, and this is what you'll get in the exam. So let's talk about beacons. So we have discussed beacons before, but this is in the general class what they will be asking us about in our exams. And folks, this is the last slide. I know we have gone quite a bit over, but we want trying to wrap up and see how much we can. So I do appreciate your patience and the extra time in the class. So what is a beacon station? Well, we discussed this already in the technician class. We discussed it a bit, I think, already in the general class as well. But a beacon station is a station that continuously, or continually rather, not continuously, continually transmit relatively low power signals, and that low power signals is maximum of 100 watts peak envelope power output, and it's for the purpose of observing propagation and reception. So remember, we had said that if you want to find out what frequency you can use where there's propagation, you could tune into those beacons. You can tune your radio to them, and you can see if you're hearing those beacons, and you can conclude, if you are, that propagation is possible between your location and where those beacons are transmitting from. That's one way to check propagation, if it's good at that time of day for you, and they can operate. And of course, those things are identified in the FCC as to what the purpose of a beacon is. Also, there are some conditions, or at least a condition, under which a beacon must comply or in order to operate, and that is that no more than one beacon signal must be transmitted from the same station on the same band. So that's the condition. You cannot have on the same band two beacons at your location. That is not permitted in order to comply with the FCC rules. Also, you can have automatically controlled beacons, and those are permitted on the frequencies between 28.20 and 28.30. So you need to learn this as a frequency range that on the HF part of the spectrum that you can have automatically controlled beacons, 28.20 and 28.30. Anywhere between this frequency range, it's permitted to have automatically controlled beacons. So on the bottom right-hand corner here, we show you an example of a transceiver that is on a frequency of the beacon itself, 28.207. And also there's a map here that shows, you can go to this website, ncdxf.org, and you will see real-time where these beacons are located and which one is transmitting on what frequency and so on. So if you wanted to see the beacons around the world, this is a snapshot of a map of their locations. And for the exam, we need to know that as hams, when we are going to transmit, to talk or to send our signals, to communicate, to have a QSO with another amateur radio operator, we need to avoid transmitting on the beacon frequencies. That will be a bummer. Imagine you have a beacon that's just beaconing so that people could establish, how well propagation is, and you go on that frequency and transmit and having a talk. That is not good at all. So we say that amateur radio operators, you want to avoid transmitting on these frequencies here, because these frequencies contain a system of beacon stations. And those frequencies are 14.100, 18.110, 21.150, 24.930, and 28.200. So become familiar with these frequencies. This will be another question in your exam. So folks, just a reminder, we have a special event that's going on in Trinidad and Tobago to celebrate our independence 59th year, which took place earlier this week, Tuesday the 31st. But the event is going on until the September 12th. We encourage you to check this website out, 9y59ind.info, for further information on that special event call that's taking place right now as we speak. And if you're a licensed amateur radio operator and you're not already involved in communicating with this special event call, check out the website for further details. Really good work by the team that's working on this event. The website has much more details than I would be able to share with you in this snippet of class. So folks, continue. We're still having some new persons join the class, so we're asking persons, the new persons in particular, review the technician class material, send me an email if you have any questions or comments. And of course, right now in Trinidad and Tobago, we're under adverse weather alert yellow, I believe, still. So we have been having quite a bit of weather since yesterday, also the Caribbean. And of course, we see what Ida has done in the US. We have some other systems also in the Atlantic as well, Caribbean Sea. So we have to be mindful and careful, everyone. And God's willing, our next session will be on Friday, the 10th of September at usual start time, 8:30 p.m. So everyone, thank you so much for your time, the extra time that you have spent. As I said, we're trying to get through all of the material as best as we can, as quickly as we can. So we've been going a little over the last 6 or so sessions, and we're just trying to finish up the material. So folks, thank you so much. All the best. Be safe and take good care. Okay, Franz, thanks a lot. Adish, all the best. All right. Sorry you lost power there, Adish. Hopefully the recording will stick. At least we have the recording done for the theory. We did not record the question pool, but that shouldn't be too much of a big deal. Okay, got you there, Franz, about Martinique following Region 1 rules, even though they're in Region 2, and Guadeloupe also. Thanks very much. Very good. You're certainly welcome, Ramzan. All the best. Adish, you too. Be safe and take good care in the bad weather as well. Yes, we have had quite a bit of electricity problems here and there. I know the local authority, TNTech, they are trying to take care of all of those issues as quickly as possible. Thanks, Franz, for posting the website link in the chat. Really appreciate it. And also congrats as well. Thank you for all of your help with that event. Yes. Okay, Jessica, take care. Have a good night also. Sylvester, good night. You take care and be safe too. June, all the best. Have a good night. Okay, Jude, you're certainly welcome. All the best to Desi. Good night. Take care. All right, Jude, good night. Have a good night. Yep, all the best. Desi, be safe. Thanks a lot for the encouragement, dear friends. Much appreciated. Okay, Ian, you too. All the best. Have a good weekend. Yeah, take care, friends. Be safe. Victor, have a good night. Take good care. Yes, I really, really do appreciate it, Franz. I mean, you bring that extra to the class, advice from practical experience, knowledge there, and I think we all learn from it. So really great to have you. And Anthony, thanks so much for the feedback. You too have a good night and be safe. All right, take good care. Certainly you're welcome there, Franz. Happy to do it. Glad you're part of it also. Okay, everyone, take good care.